Okay, a'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin wassalatu wassalamu ala asyrafil mursalin sayyidina wa maulana Muhammad wa ala alihi wa sahbihi ajmain. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbi yassir wa la tu'assir. Wahai Tuhan, terangkanlah dadaku, permudahkanlah urusanku, bukakanlah simpul lidahku, supaya mereka memahami kata-kataku. Wahai Tuhan, permudahkanlah, jangan sukarkannya. Amin, amin, ya Rabbal Alamin. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good morning, ladies and gentlemen. Okay, my name is Nurul Huday binti Abdullah from Center for Diploma Studies, UTHM. Okay, it is my pleasure to welcome you all in this sharing knowledge today. So I would like to thank you for joining us today for this special presentation on environment open mic case study and sharing session part 1 inshallah. Next time part 2 inshallah. Okay, so for this session, very interesting to sharing regarding introduction and application of mass transfer factor modeling, MTF and MMTF models. Okay, so now I would like to introduce our special speaker, Professor Dr. Mohamad Fulazzaky. Okay, from School of Postgraduate Studies, Universitas Djuanda, Bogor, Indonesia, and also as Research Fellow at Water and Wastewater Research Group, Faculty of Engineering, Universiti Teknologi Malaysia, UTM. Okay, for your information, Professor Ali will explain regarding introduction to mass transfer factor, MTF, and modified mass transfer factor, MMTF. Model. Okay, this explanation very important because this is the basic knowledge regarding mass transfer factor modeling, and this basic info have been implemented on speaker project. Okay. Okay, so now let me introduce our first speaker is Dr. Hairul Khamidun as a senior researcher at Universiti Hussein on Malaysia, my colleague. The sharing title today is Development and Application of Mass Transfer Model for Adsorption of Ammonium and Phosphate from Wastewater. Okay, our second speaker, Dr. Maria is a senior researcher at University Teknologi Malaysia, UTM, and her title is Mass Transfer Kinetic of Biosorption of Organic Matter from Anaerobic Digested POME by Biogranules in Sequencing Batch Reactor. And our last speaker is Dr. Atikah binti Abdul Salim as a senior researcher at UTM also, and her title is Reliability of the MMTF model to describe the absorption of phosphate by waste master shell. So, ladies and gentlemen, I am honored to invite our special speaker, Professor Ali, today to start our sharing knowledge. Okay, welcome, Prof. Okay, so all participants, if you have any question, can ask on Zoom chat anytime. Thank you.
Okay, I would like to share my presentation. Yeah. Okay, you can see there.
Okay.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody who attend this talking session on case study and sharing. I will introduce to you what I have developed a mass transfer factor model and also modified mass transfer factor model. We looking at histories of this model. Mass transfer factor model I developed when I stayed student in France. It's part of my thesis. And then I've tried to publish, I have published it in International Conference on Irrigation and Drainage in Montreal, Canada in 2002. And then after that, when I joined with UTHM and UTM, I published two articles using mass transfer factor model, first in Chemical Engineering Journal and analytical method. And then I published with my postdoctoral student in Chemical Engineering Journal. And then the model was modified. Then we call modified mass transfer factor model in 20013. Why this need to be modified? Because we look at the reality that water contains many elements. It's very complicated. But with this model, we can use more wide application of the model. But a mass transfer model is very limited only for absorption of one pollution. And this model, an MTF model, we published about 10 articles authored by myself as correspondent author. But maybe Maria, Atikah, and Hairul also other published. I don't record here. I record only the article that I published with I am myself as correspondent author. And then we look about the development of MTF model. If you see here, the model is developed based on Fick law of mass transfer. You can see here, if we have liquid and then film zone and then porous and then fixation. The step of mass transfer is we're passing 3 successive steps. The first what we call is film mass transfer. This from bulk water to film zone. This because we have driving force. We have difference between C and C starts. And then porous diffusion. Porous diffusion is within the pore. The solute move within the pore. And the third step is fixation. Is here. Fixation to adsorb into the active site. Because the fixation is very fast, what we consider the absorption will be controlled by either film mass transfer or external mass transfer or porous diffusion or internal mass transfer. Only these 2 steps is very important to consider when we absorb something from liquid to solid phase. And then you can see here how we develop the model. First, please consider about the continuous equation. The equation are writing to set up a specific case. There's 2 cases. The first is at the level of elementary volume in case of continuous medium. The second is at the level of system or part of system in different conditions of functioning. This our case is the case 2, not 1. And then we can look regarding the microscopic balance is to develop the balance of elementary volume, dx, dy, and dz in space using equation of diffusion according to Fick law. This is very difficult to develop. This we should have a very strong mathematics to develop, because dx, dy, dz, how to move up, down, and pass through and go back and so on is very difficult. And then to simplify that, we use the macroscopic balance. Macroscopic balance is to write general equation of mass transfer interfacial gas liquid, or in our case is liquid solid, to the level of system or part of system for different functional condition. And then I develop a mathematical model. How can develop? By assumption that the flux flow column reactor is a black box. With that, we can define quantity of solid transferred per unit of time and A, and mass transfer coefficient KLAF, and surface area S, and driving force. This difference between concentration and concentration start. Concentration start, this means concentration at film zone. And this equation, we can develop the equation. This from definition become a equation. This is why we call the MTF model is theoretical base of model, not empirical. Okay. And then look here, the model of flowing, the schematic of flow model, C and CS. And this C and C different C, like that. And then we can develop model, the model of mass balance, entrant equal departure plus absorbed. And then absorbed, we can define it by this, and then we can develop this model, and by some assumption, we have the model like that. And then we have the correlation between film mass transfer or external mass transfer and global mass transfer like that. And then we can write the equation like that. This is what we call the mass transfer factor model, or you can say Fulazzaky equation, up to you. This, to simplify that, we need to write in form of linear equation. This in linear equation, Q equal B, blah, blah, blah. And then B defined as this, blah, blah, blah. And then you have a relationship between global external of film and internal of fluid diffusion like that. So this equation, look here, before modified, here we write Q, but after modified, learn Q. This modified is empirical equation because I didn't develop theoretically, but only use the data, the real data, and then we plot ln Q versus ln T, and we have a very, very good correlation for the model. And this applicability of model can be expanded because when we replace Q with ln Q, this and then ln Q, versus lumpy when we trace the curves. The purpose of this model, these two models, MTF and MMTF, these two models exist and are valid, and yeah, it depends on the case study. Yeah? First is to understand the kinetic of and mechanism of mass transfer. And we look about this case, is many model has been developed for that, but the application of model is very limited. Maybe Atikah can explain for that, yeah, because we have other model when we analyze it, they have some limited, and then when we use the MTF model, is very good, yeah, very valid for explanation, experimental data. And then to determine resistance of mass transfer, this typical applicability of these two model, MTF and MTF model, because we don't find any model to determine clearly resistance of mass transfer. And third, propose to develop correlation, but I have tried for that, between mass transfer factor and reactor performance. This in progress. We have also analysis new article with Professor Khalida regarding this case, how to eliminate or decorrelation of day in the reactor system, not like with Udin by using fungi, but this in the reactors. I think we will be successful that. The basic knowledge of MTF and MTF model, we can see here the difference between the two models. And if we look the nature and year development, MTF is theoretical equation. This developed in 1996, and MTF model, empirical model, developed it in 2013. When we look the curve plotting, MTF model, we plot Q versus ln T. But MTF model, we plot ln Q versus ln T. The application of model for MTF model is just applicable for single solute. It is a specific case, only for single solute. But for an MTF model, we can use for wastewater, river water, well water, and so on, because they contain multivariate solute in water. So we can use that then. This wide application of the model. When we look at operating condition, MTF model is very specific, but an MTF model is general. Challenge for you as researcher or student, many challenges. You can look at the variation of KLAG, KLAF, and KLAD. This can be plot versus first percentage of outflow, second time, third accumulated amount of solute absorbed into absorbent, and then accumulated amount of solute released from absorbent, and then percentage of solute removed from solution. If you have published any article, you use only one of these, you can maybe modify, you use another version by floating KLF versus anything that you have not yet float this. This I have tried for in progress now for one article. I plot between KLG, KLF, KLD versus accumulated amount of absorbent adsorption. But in case of Shakila, Maria, and so on, might be different. And we can see also this model we can apply for many types of reactors. For example, here batch reactor for gas preservation, we can use this. Sequencing batch reactor in case of Maria, this use the sequencing batch reactors. Incubation reactor, the case of paper I write with Udin, is use incubator reactor. And also you can use hydrodynamic column, fluctual column reactors like case Atikah, Hairul, and package bed column reactor case Shakila. It's many reactors we can. Other reactors you can use also, but the principle if you should have accumulated amount over time. This is the key what you should remember in your mind. Yeah, you should have accumulated amount of solutes over time. The use of mass transfer and mass transfer method could be useful to study the mechanism and kinetic absorption, biosorption, desorption, precipitation, declusion. But I don't have case about regarding the desorption. Maybe you can use this for your research. Then you will have a good novelties for that because we don't have explained the case of desorption with this model. So if you see the implementation of MTF and MTF model for different reactors, for example, hydrodynamic reactors, we have published 6 articles, this article this year, and package bed reactor 1 article, and this year publishing sequencing batch reactor, we have published 3 articles, and this year of publishing batch reactor 1 article, and incubation reactors 1 article. These are some statistics you have. What we want to tell to you that the interest of reader for this model is more interest than other of my publication because citation of this model is more comparing with other publication. This some article they have published is all article we publish in Q1. More in Q1, but we have also published Q2 and Q3 in WAS, what 5%. Maybe in Scopus almost Q1, but only 2 in Q2. Yeah, that's mean this model is very interesting if you want to publish your article using this model, because we have published in a high quality journal. It's Q1 recorded in WAS. That means it's very good journal. This the last was the conclusion. The MTF and MTF model as a new kinetic model can be used to investigate the mechanism and kinetic of solute removal by different type of reactors. Yeah. Wide range of model application comparing with other model like friendly, Klangmir, so on and so on. It is very limited, but this model is very wide application. And then curve of the mass transfer factor observed from different process is different from each other. If you find the curve different, you don't shock with this. This the reality. but you need how to explain. This is very important, to understand and explain of using this model. Wide range of interpretation can be made, yeah. And then a number of citation I have explained you is more interesting of reader use this model, comparing with other of my article published in the journal. The perspective first is the applicability of MTF and MTF model need to be expanded to many other case study to cover a wide range of engineering system. This you as researcher, I hope you will apply this model for to develop, to expand for many other cases. And then the applicability of MTF and MTF model need to be extended for describing the mechanism and kinetic of disruption, because I don't have explained yet for the case of disruption from solid into aqueous solution. Yeah. This the controversy from adsorption is disruption. And the third is determination of design parameter proposed to correlate mass transfer factor and reactor performance need to be considered in the future research. This for application in engineering for the next. And this very first for application for design of reactor and so on and so on. I think this is what I tell to you for this morning, and thank you very much for your attention. And Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Prof. Prof, can I ask one question?
Okay.
Prof, maklumkan ada boleh kita buat batch reactor. Andai kata kita buat batch study, batch experiment that tiada nilai Q pun. Q tiada. Flow rate means flow rate. Jadi dia applicable tak untuk kita gunakan this modeling?
Batch reactors. Kenapa tidak ada Q?
Tapi dia bukan batch study that kita gunakan, mungkin kita dalam conical flask, tapi tiada in out, just masukkan absorbent di dalam conical flask, then dia shake selama beberapa certain time, then kita akan check berapa kandungan phosphate di dalam air tersebut. So dia tak ada flow rate.
Dia tak ada flow rate tapi ada accumulation.
Yes.
Over time dia accumulation. When you measure 1 minit, 2 minit, 1 jam, 2 jam, 3 jam, dia akan amount of solute absorbent bertambah.
Okay.
So itu ada accumulation. If you have accumulation over time, you can use this model.
Okay, tapi saya tengok ada analisis daripada Dr. Atikah, dia perlukan nilai Q, iaitu flow rate. It means volume over time. Jadi ada sesuatu, saya tak ada nilai tersebut. Jadi macam mana nak dapatkan nilai flow rate tersebut, Prof?
Itu lihat case Zohreh. Zohreh dia guna only one flash.
Okay.
Jadi only one flash, flow rate gunakan berapa yang ditambah saja.
Okay.
Itu ketambah sekali.
Ya, tambah satu kali je yang first.
Itu saja. Yang paling penting dia ada accumulation versus time. Coba baca baik-baik case Zohreh.
Zohreh. Tahun bila, Prof?
2017.
2017. Okey, baik.
Dia you baca itu boleh, karena kalau yang saya punya yang 2012 atau 2011 itu gunakan plug flow column reactor. Jadi dia continuous hydrodynamic column. Jadi yang betul-betul best itu adalah punya Zohreh.
Oke.
Itu betul-betul batch. Yang penting ada accumulation over time. Ya.
Okay.
Nanti kalau ada kesukaran boleh pergi rule data saya, nanti saya betulkan. saya.
Terima kasih, Prof.
Ya.
Okay. Thank you, Prof. Thank you for sharing brilliant knowledge. That I hope that after this we can apply our research analysis using mass transfer model and also modified mass transfer models. Okay, ladies and gentlemen, so we move to sharing session for our speaker, Dr. Atikah binti Abdul Salim, Dr. Nur Atikah binti Abdul Salim from UTHM to explain regarding reliability of the MMTF models to describe the absorption of phosphate from waste master shell. Okay, welcome Dr. Atikah.
Assalamualaikum and good morning, everyone. I hope everyone is doing well. I'm Atikah from the School of Civil Engineering under the Department of Environmental Engineering. Today, I would like to share about the reliability of the MMTF models to describe the adsorption of phosphate from wastewater by waste master shell. First of all, why it is important to evaluate phosphate? It is because high levels of phosphate released into receiving water causes water quality problems. In this work, the adsorption of phosphate from wastewater onto waste master shell was conducted in column experiment. The MMTF models were used to determine the resistance of mass transfer, which is dependent on either film mass transfer, FMT, or porous diffusion, VD. The results verified that the efficiency of phosphate removed from wastewater by hybrid low column reactor HPFCR reached 96%. The phosphate concentrations of 0.26 milligram per liter detected in the treated wastewater, which can convincingly meet the international effluent standard. Based on the curves in figure 8B and 8C, the value of KLF and KLD against phosphate breakthrough can be used to determine the resistance of mass transfer, which is dependent on film mass transfer or porous diffusion. KLF is film mass transfer FMT factor, while KLD is porous diffusion PD factor. The KLD values as shown in figure 8C2 are all lower than the KLF values as shown in figure 8B2 with increasing phosphate breakthrough. Therefore, this study justified that the resistance of mass transfer for adsorption of phosphate onto waste master shell is dependent on porous diffusion. In the future, the MMTF models can be used to describe the adsorption of phosphate from wastewater or contaminated water by various natural materials such as egg, oyster, cockle, and crab shells. This study produced waste master shell, WMS adsorber, and hybrid plug flow column reactor, HPFCR treatment system for removing phosphate. One article with impact factor 2.984 and 2 book chapters. we hope that this HPFCR treatment system can be expanded towards real applications to help improve water quality, especially for our people, our community, our state, and our country. With that, thank you for lending your SNR. Thank you very much for your kind attention.
Okay, thank you, insyaAllah. Okay, thank you for Dr. Atikah for your sharing knowledge today. Ladies and gentlemen, in 2022, Prof. Ali and Dr. Atikah have been published 3 manuscripts regarding this application of modeling. Is it correct, Dr. Atikah? This year?
Betul kan, Prof?
Okay,
Betul kan, Prof?
one of the...
Cuba tanya, Prof.
Is it?
Tiga.
Yeah, okay. One of the latest manuscript, the title is The Mechanism and Kinetic of Phosphate Absorption onto Iron-Coated Waste Master Shell observed from HPRC tadi, hydrodynamic column. And so if you all want to study further, you can search this journal at Scopus and also website lah, insyaAllah. Okay, thank you Dr. Atikah, very brilliant sharing knowledge, insyaAllah. So we move to Dr. Maria. Dr. Maria from UTHM to explain regarding mass transfer kinetic of biosorption of organic matter from anaerobic digested by biogranules in sequencing batch reactor. Okay, welcome Dr. Maria. Wait a minute, I share the screen first. Okay.
Okay, thank you to the moderator, Dr. Nurul Hudai Abdullah. Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamualaikum warahmatullahi wabarakatuh, and very good morning to moderator and all the speaker, especially to Prof. Ali Fulazzaky, Dr. Nur Atikah, and to all the audience today. First of all, I would like to thank to UTHM to invite me in this session. Okay, a little bit information about myself. My name is Maria binti Nuid. I'm a postdoctoral at the Center for Environmental Sustainability and Water Security IPASA, UTM, and I get my PhD, master and degree in civil engineering also from UTM. Okay, the title of my part today is about mass transfer kinetic of biosorption of organic matter from anaerobical digested palm oil mill effluent by biogranule in sequencing batch reactor. Okay, next. This is the overview of my talk today. It's about a little bit about introduction to biogranule, the application of biogranule on MMTF model, and the last but not least is conclusion. Next. Okay, what's a biogranule actually? Biogranule is a imaging treatment technology. It's a technology that brings significant benefit such as reduction in footprint, low operational cost, less energy use and chemical consumption, excellent biomass settle ability, along with the stronger tolerance to toxicity exposure and shock loading. Okay, next. It is also deliver improved environmental compliance and robustness compared with other traditional wastewater treatment technology. Okay, next. Why you must use the on MMTF model? Okay, actually MMTF the purpose of this study was to use the MMTF model to access the biosorption of behavior organic matter or total and soluble COD from the anaerobical digested POME before and after the addition of Ceresa marsensian SA30 or SMSA30 strand into the biogranule system. The aim is to much understanding to wide applicability of this model and thus provide valuable insight into the biomass accumulation and biogranulation process. Okay, actually from this data, we focusing on the assessment of total and soluble COD removal efficiency. This is because of the poor treated anaerobical digested POME quality that release into the environment. If you can see from the graph, plot of lone Q versus lone T yield a straight line where 1 over beta is a slope and B is the y-intercept. From this line, we can see the linear regression analysis as very good fit for all the parameter, which is R square is greater than 0.910. It is indicate that the parameter for beta and B can be used to describe the kinetic and mechanism of the total and soluble COD. If you can see from the graph, the value of B and beta is increased when the addition after the addition of SMSA30 strand into the biogranular system. Okay, next. These figures show the value, the series plot of KLA before and after the addition of SMSS strand. A and B is represent the total and soluble COD before addition of strand, and C and D is represent the total and soluble COD after the addition of strand into the system. You can see the zigzag pattern actually of the KLAG and KLAD value is very similar for all the experiment, and the value is very high compared to the KLAF value. The result indicate that the resistance of mass transfer is actually depend and controlled by the external mass transfer. Is represent of KLAF for transport of substrate from the bulk water to extracellular precipitation. For EMT, when a liquid flow through a biogranule, there exists a region near the biogranule surface where the liquid velocity is very low, giving rise to near stand film of liquid, which is of maximum resistance to transfer of substrate to the biogranule surface. Okay, next is the figure is show the correlation of global mass transfer to organic matter removal efficiency. From this graph show the study is the performance of the biogranule system actually increase logarithmically with increasing of global mass transfer rate. Next, the last is the conclusion from my study. The result of the MMTF model actually show that the total and soluble COD biosorption by biogranule in the SBR system is controlled by resistance of external mass transfer, EMT. And also, this study also verified that the removal performance of the biogranular system treatment increase when they increase the GMT, global mass transfer rate. Okay, thank you.
Okay, thank you, Dr. Maria. Okay. Okay, thank you for sharing knowledge, Dr. Maria. Ladies and gentlemen, you also can refer on publication Dr. Maria and Professor Ali regarding her study entitled Mass Transfer Kinetic of Phosphorus Biosorption by Aerobic Granules, and have two other manuscripts have been published to Journal Environmental Teknologi, United Kingdom, and Process Safety and Environmental Protection regarding this modeling. Okay, thank you, Dr. Maria. So, okay, we move to Dr. Hairul. Actually, Dr. Hairul have a big meeting today. So, he give the recorded video. So, I will share the screen for recorded video from Dr. Hairul. Okay, wait a minute. Okay, ada nampak ke?
Yes, clearly.
Nampak.
Okay, thank you. Okay.
Assalamualaikum and very good mornings. Thank you to the organizer to invite me to give us some knowledge sharing in this session. Okay, first of all, I want to apologize to all the audience, okay, because I cannot attend as a live telecast in this session. So because I've had a certain program that is earlier scheduled, okay. So my name is the Mohamad Khamidun. I'm from the Faculty of the Civil Engineering and Built Environment, Universiti Hussein on Malaysia, UTHM. So for today, I would like to sharing about my study, okay, related to the mass transfer model. Okay, I think the previous session already given some information or some knowledge about what is the mass transfer model by Professor Dr. Ali. Okay, I'm the student, former student of Professor Dr. Ali. Thank you very much for the good supervision to me, okay, during my PhD. So for today, I would like to sharing about the development and application of the mass transfer model, okay, for absorption of the ammonium and the phosphate from the wastewater. Okay. Okay. This study. So what I'm doing, what we're doing for this research. So the first of all, we want to to apply the apply the mass transfer model. Okay, that's basically they use the mass transfer model for the single solute. Okay, in this case, we try to use and modify, okay, the mass transfer from the single solute that we use the multiple of all the various solute. The first of all, the problem about the multiple of the solutes, and we want to identify, okay, and understand about the mass transfer, the mechanism, okay, the first of all, the pollutant, okay, in this raw water, okay, in this part, the problem from the raw water. So for the excessive amount of the ammonia and the aluminum in the raw water, and second, we try to use the modified mass transfer model and apply to the wastewater effluent of the wastewater treatment plant, okay, that have the high concentration of the ammonia and the phosphate, okay. And in this study, we use the mass transfer. In the other step, we use the adsorption process. Okay, we need to the separation of the ammonia, aluminum from the water and attach on the adsorbent. Okay, and then we can understanding and identify the mechanism, okay, of the mass transfer. We either the mass transfer occur in the film mass transfer, okay, forward diffusion, and we will understand the whole, okay, the overall, the global, okay, global of the mass transfer. Okay, that's why in this study we can understand what is the modified mass transfer factor atau mass transfer model. Okay. Okay, objective in this study, okay, in this case study. So the first to hypothesis and develop the modified mass transfer model. That is the I mentioned previously. The first mass transfer model is to apply for the single solute. But in the study, we try to use the multiple and or the various solute in the water. Okay, and then the second objective is to justify. Okay, to justify the validation of the developed modified mass transfer factor to determine the kinetic and adsorption and verify the application of the empirical model and the modified mass transfer factor model. But in this session, okay, I just want to sharing sharing about the mass transfer model. Okay, the adsorption kinetic and the others empirical model. Maybe all of them can contact me if you want to the further information or information about or knowledge about the kinetic isotop of the others model. But in this session, we just focus on the mass transfer factor model. Okay. Okay, this is the setup. Okay, empirical setup. The first objective or the study. Okay, in study case, we develop or we conduct to understand. Okay, ataupun to develop, okay, of the modified mass transfer factor model. Okay, this is the figure out or description that the reactor we set up consists of the collar, okay, peristaltic pump, and then have the certain water storage, and then here is the main characteristic. Okay, in this column we fill in with the granular activated carbon. Okay, and here is the characteristic, okay, the explanation of the characteristic, what the characteristic of the GAC that we use in this column. Okay, this is dimension. Okay, we have the diameter column, okay, depth of the GAC, volume, okay, weight of the GAC, okay, flow rate and the hydraulic. All this study we success to publish in the impact factor journal. You can find this paper in the journal environmental engineering, chemical engineering, okay, journal. You can find this paper. Okay, and the second we set up for this one for the validate the application of the modified mass transfer factor model, and then we test again the modified. The first we just develop, okay, by using the two solute consists of the ammonia and the aluminum, and then we successful to develop for the modified mass transfer factor model. And then the second study we use the modified mass transfer factor model, and then we try, okay, to use for the others adsorbent, okay, the others adsorbent such as the laterite, okay, zeolite, and also we still maintain to use the granular activated carbon, but the different characteristic of the granular activated carbon. Okay, and the second study, okay, we set up for using the wastewater treatment plant effluent. Okay, the first study we use the raw water. Okay, the second one we use the complex, okay, the complex of the constitution of the water. Okay, so this is the characteristic of the sewerage treatment plant. Okay, sewerage treatment plant. So we analyze, okay, the certain parameter of the pollutants such as the COD, suspended solid, turbidity, DO, pH, phosphate, ammonia, chloride, okay, sulfate, and conductivity. And then here is the dimension of this one we call as the hybrid part flow column reactor. Okay, because we consist of the two systems. Okay, consist of the filtration, and then after the filtration, and we proceed for the adsorption punya process. Okay, adsorption process. Okay, why we put in the filtration? Because we use the wastewater treatment plant, okay, effluent, so they still have the certain suspended solid, okay, and others can can be affected to the performance of the adsorption, okay, to remove the ammonia and phosphate. So we need to the secondary treatment before we proceed for the adsorption process. Okay. Okay, this is the model development from the single single solute, okay, the basic of the mass transfer factor model. And when we try to modify, okay, this study this study is the supervised by Professor Dr. Ali. Okay, so he have the whole idea, it come from him. Okay, and then I just to apply and use the modified model to use for the others adsorbent. Okay, I thought this one already taught by Professor Dr. Ali. So this one I just repeated again. Okay, this is the mechanism. Okay, mechanism of the mass transfer model. So from the bulk water, and then we proceed to the film zone, and then go to the pores, and then become as a fixation. Fixation is the rapid process. Where is the solutes will be attached on the pores in the quickly. Okay, so the first of all we use this formula. Okay, we need to plot. Okay, plot the ln Q, okay, versus the time, and then from this plotting we can calculate. Okay, we can calculate or identify the slope. Okay, the slope we can determine the beta is the adsorption affinity. Okay, so that constant we can understand about the adsorbent affinity, and then in this intersection we can find the value of the driving force. So they have the two constant in this model. Okay, we can understand. Okay, we can more understand about the affinity of the adsorbent and also the driving force. Okay, the value of the driving force. Okay, this is the way how we can use the modified mass transfer model. Okay, we plot ln Q versus the T, and then we can determine for the B and beta, and then from that we can calculate for the KL global, film mass transfer, and the pore diffusion. Okay. Okay, this is the result. The first study, we use the raw water and to identify the adsorption of the ammonia and the aluminum. Okay, so the result for the ammonia and the result for the aluminum, and then is the combination adsorption or resistant mass transfer of the ammonia and aluminum. Okay, so this figure, okay, we can understand the mechanism whether the resistance is occur at film mass transfer or pore diffusion. Okay, we can identify. Okay, so the black color is the global. That means the summation. Okay, summation of the film transfer and pore diffusion. Okay, and the red color is the film mass transfer, and the green one is the porous diffusion. Okay, porous diffusion. Okay, for the ammonia, aluminum, they show the same trend. Okay, the same trend. Okay, but the different value. Okay, and when we combination, we can get the same trend of the ammonia and aluminum. Okay, for here we can find that the mass transfer, okay, is dependent on the film mass transfer. Okay, film mass transfer. The first, okay, film mass transfer is the rate. Okay, the value is the low. The low must that mean, okay, there we can define as the difficult. Okay, difficult of the solute to adhere or to attach on the activated carbon or the adsorbent. So here, okay, this is more clear. The first, the mass transfer is the dependent. Okay, the resistance of mass transfer dependent on the film mass transfer, and then after the breakthrough, so we look at the value will be increased. Okay, the value of the film increased, but the value of the pore diffusion will be decreased. Okay, when the decrease, that means the resistance, okay, shift, okay, from the film mass transfer, the shift to the pore diffusion. This is how we can describe, okay, how we can describe about the mass transfer resistance. Okay, this study just using the ammonia and aluminum, okay, two solutes. Okay, and then The second, we try to verify. Okay, we apply that modified mass transfer factor, and then try to the various of the adsorbent, such as the laterite, zeolite, and also the granular activated carbon. Okay, we try and study. The first thing we need to plotted ln Q versus of the time. Okay, ln Q versus 4. But this study, we have the another factor. We use the different height of the adsorbent. So we have the 6 different height from the 2, 4, 6, 9, 12, and the 15 centimeter of the adsorbent. Okay, so we can get the plotting the ln Q versus T, and then when we verify the constant, the beta and B. So beta related to the affinity between the adsorbent and adsorbate, and the beta is the related to the driving force. Okay, due to the different height, different height that they use in this study, we can find the beta affinity between the adsorbent will be decreased. Okay, when the height will be increased. So that's mean the due to of the numbers. Okay, numbers of the active site. Okay, now because of the largest height of the bed is the 15 centimeter. That means they have the lot of the active site on the adsorbent. So the more easier to accept the phosphate ion attached on the laterite. Okay, that's why the affinity is the lowest compared to the shorter of the bed. Okay, meanwhile for the beta can be described as the driving force. Okay, in this case, the lowest or shortened bed height is the 2 cm. The beta, the B, driving force is the highest. Okay, this is due to the different concentration during the bulk and then on the film. Okay, so because the bulk is to have the height of the concentration, and then the concentration in the film is the lowest, so they have the huge difference between concentration in the bulk and the film, and that's why they have the excessive of the driving force. Okay, compared to the highest of the depth. Okay, higher the depth, the driving force is the more lower, because it's more stable. The concentration between the concentration on the bulk and the film is not much different, so they have the low of the driving force. Okay, so based on this model, modified mass transfer factor model, okay, we can understand about the affinity, affinity between adsorbent, and also we can describe what happened in the adsorption process, what happened during the mass transfer. Okay, what is the factor, the constant of the driving force. Okay. So this is the explanation for the global. Okay, the global, as I mentioned earlier, global is the summation of the film and pore diffusion. Okay, we have the trend. Okay, the quick. Okay, start quick and then suddenly to decrease, similar to the film and pore diffusion. Okay, from this one we can find that the lowest value, negative value, is occur at the pore diffusion. That means the resistance of mass transfer is dependent on the porous diffusion. Okay, porous diffusion. That means the solute of the ion of the phosphate, favor attached on the surface, on the film of the adsorbent, compared to, and difficult to penetrate on the porous diffusion. Okay. So this one for the ammonia onto the zeolite. Okay, they have the same trend. Okay, because they relate to the mass transfer. Mass transfer play around with the concentration and also the numbers of the active site. Okay, the active site. So they have show the same trend of the beta. Okay, and the same trend of the B. Okay, same trend of the affinity, higher at the 2 cm and lowest at the 50 cm, and also the beta, they will decrease. Okay, when the height of the concentration. So based on application of the ammonia onto zeolite, so in this study have the same trend as the adsorption of the phosphate onto the laterite. Okay, for the trend, okay, they are different, slightly different. Okay, the value of the resistance, but they have the same thing happen when the resistance of mass transfer is occur dependent on the porous diffusion. Okay, so we can find that the increase the bed depth, okay, was decrease the diving force. The value will be decreased because of the difference of the concentration on the bulk solute to the film solute. Okay, this is the ammonia onto granular activated carbon. Okay, good correlation. Okay, R square more than 0.9 and beta and B decrease with the increasing of the height. Okay, the affinity and diving force will be decreased because they depend on the concentration, and another one is the active site. Okay, they have the more surface, and then the affinity is the more lower because they have a lot of the space. Okay, a lot of the space to occupy by the solutes. Okay, and then the thread similar, this one for the filler, and then this one for the pore. Both the application of the application of the modified mass transfer model use the laterite, zeolite, and the granular activated carbon. Assure the resistance of mass transfer is depend on the porous diffusion. Also, on this finding, okay, they will give the ideas. Okay, they give you ideas. So when you analyze and then you study about the adsorption and then you find the resistance, okay, resistance of the mass transfer is occur the pore diffusion. So that means when you want to modify that the adsorbent, so you can be focuses how to increase the pore, because the problem of this study, the finding of this study, they found that the problem solute or ion of the phosphate or ammonia difficult to enter into the pore diffusion. So we have the idea. So for the others or further study, we need to find others method how we can increase, okay, the pore in this adsorbent. Okay. And then conclusion, okay, so we already verify that the modified mass transfer model, okay, can be described the global, external, and internal. That means the film and the pore diffusion. And resistance of mass transfer of the solution of the one or more solute we present as surface water and also in the effluent wastewater verify, okay, and then contribute to engineer improve adsorption capacity. That's I mentioned earlier. So when you want and when you get the finding, the adsorbent is quite difficult to penetrate in the pore diffusion. So you can modify on the porous characteristic, okay, the properties of the porosity on the adsorbent. Okay, that's all for me. For the sharing is about my study, okay, related to the mass transfer model. So if you want to find me, okay, you can find any research platform such as the Scopus, okay, and you can find in the Google Scholar and also in the ResearchGate. You can find out what is the current study that conducted by my group. Okay, you can find here. And also if here have the student interest to further study for the master and master research. Okay, so here I have the certain topic, okay, that required for the master student. So kinetic and adsorption and also mass transfer model using the concrete waste. Okay, so that's all from me. Thank you for all to listen me, and if you have any question, you can contact me. Okay, contact or WhatsApp or you can email to me. Okay, thank you all. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Alhamdulillah, alhamdulillah. Okay, thank you, Dr. Hairul, because he gave this recorded video regarding his study. And ladies and gentlemen, actually Dr. Hairul is the first graduated PhD student under Professor Ali Fulazzaky at UTHM 2015, and he applied this modeling on his study since 2011. Okay, thank you Dr. Hairul for his contribution for this sharing knowledge. Okay, I hope that after this sharing, we can apply our research analysis using mass transfer model, and then we can go further next session, next sharing session and networking after this, inshallah. Okay, due to our insufficient time, ladies and gentlemen, if you have any question that you want to ask, so you can ask on this Google form. Okay, let me share Google form for attendance. Okay. And then before we wrap our online webinar today, we want to take a few photos. So ladies and gentlemen, hope you all can open your camera so we can take the picture. Okay. Prof, ada kenal Agila Rajan tu, student Prof dulu di UTHM?
Kenal di UTHM.
Sekarang di Sarawak kan Agi?
Oh ya, Agi di Sarawak.
Ya Kak. Ya Prof, dekat Sarawak.
Sudah jadi pensyarah sana?
Tidak, buat pengonyo, buat highway kat sini.
Engineer Prof, engineer di sana.
Uday, bagi kesempatan kalau ada yang bertanya.
Oh, okey. Kejap kita ambil gambar sekejap. Dia orang dah buka kamera. Kejap Okey. 1, 2, 3. Okay, wait a minute I copy this picture first. Okay, 1, 2, 3, senyum. Okay. Thank you, everyone. Okay, so if you have any question, you can ask Dr. I open the question Q&A session for 5 minutes. If you have any asking, so you can ask Dr. Ali or our speaker, Dr. Atikah and also Dr. Maria. Okay, silakan. Sekiranya ada sebarang soalan. Dan sambil-sambil juga anda boleh isi Google Form dan kita akan sediakan e-sigil dan email kepada hadirin-hadirat sekalian lah. Okay. Prof, udah ada nak tanya soalan? Oh, okay. Hairul Azman. Okay. May I ask, do MTF and MMTF models hold for any kind of absorption process? Ni my FIP student ni, Prof.
Siapa?
Student udah FIP. Soalannya, may I ask, do MTF and MMTF models hold for any kind of absorption process?
Yeah. You can use for any kind of certain process. The principal thinking is you have accumulation of solute absorbed over time. The important thing.
Okay.
You can use for any kind of reactors. It's no problem.
Okay. Jadi kiranya walaupun batch eksperimen sekalipun masih boleh, tetapi refer on Zohre journal.
Ya, boleh buat. Ini saya tengok ada dari Indonesia juga ya, dari Polban, dari ITS, dari Universitas Djuanda. Kesempatan kalau mereka yang mau bertanya.
Silakan. Sekiranya if you have any question, you can ask Dr. Ali Fulazzaky. Prof, ada cadangan tak nak buat buku regarding MTF and MMTF? Sebab rasanya ini adalah satu basic theory and also fundamental that we can refer selain daripada refer on journal.
Boleh. Itu harus aktifkan Maria, Atikah, Hairul, aktifkan buat nanti saya cek.
Mungkin kita boleh sediakan outline dan kita bahagikan supaya mereka semua diorang tahu cara penggunaan this modeling lah.
Ya, boleh. Ini jadikan buku. Boleh.
Okay, insyaAllah next perancangan insyaAllah. Okay, Prof. Maybe kalau sekiranya ada sebarang persoalan, saya ada sediakan Google Form tersebut dan ada soalan sekiranya ada malu-malu untuk bertanya lah. Okay, so thank you. Ladies and gentlemen, that wrap our sharing session today. Thank you again to Professor Ali, Fulazzaky, Dr. Hairul, Dr. Maria, and also Dr. Atikah for making time in your busy schedule with us lah today. Inshallah, all good thing are from Allah and everything bad come from my weakness. And inshallah, I will try to improve myself. And thank you for all participants for joining us today. Don't forget to fulfill the attendance today at chat space. And then we wrap. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you, everyone. Bye. Thank you. Thank you, Agi.
I leave ya.
Yeah. Thank you.
Thank you, Doctor.
Ya, sama.
Sama.
Thank you, Doctor.
Ya.
Thank you, Doctor.
Thank you, Prof.
Okay, Dr. Rifai, IRTS Hafiz, Narish Kumar, you can take this Google form, fulfill this Google form. Thank you. You're welcome, Doctor.